Hello and welcome, coming to you once again, not quite live from One Take Studios, where today's topic is exploring transformations. Big words, crazy words, but words have meanings, and if you don't let the words scare you, this is actually not too bad, alright? We are going to focus on essentially two types of transformations today. We're going to see translations first, and then we're going to focus on stretches and compressions, and especially comparing the two, because this can get really weird, and I'm going to hope to make it less weird for you. Alright, today's lesson is brought to you by the colors green and orange, and so hopefully we can tell those things apart on paper, shall we? This graph that I made for you is just a generic graph. It doesn't have anything in particular. It's got points, it doesn't have an equation, and we don't need it to have an equation right now, not to do what we are doing today. Translation, you'll see horizontal and vertical here on both sides. Translation is the key word for this page. And to translate something is to slide it over, all right? So just take something wherever it is. So if I want to translate this pen, I'm going to take this pen and just slide it over, and that's a translation. So let's focus then on the difference between vertical and horizontal. Those are words that you need to know, and if you don't, I would jot them down if I were you just to keep them straight. But vertical is an up and down thing, and horizontal is a left and right thing. So if we're thinking about a coordinate plane, XY axis, the y-axis is the one that goes up and down. That's going to describe our vertical changes then. And the x-axis is the one that goes left and right, so that one's going to affect our horizontal changes. Alright, let us start with the vertical translation then, and let's say that we would like to take the vertical translation and go, let's start with green here. Let's go up 3 units. So we're going to take the entire graph and move up 3 units. Again, not focusing on any sort of equation, just look at the points. What do we have here? Alright, so this point right here is currently on the x-axis, and I want this point to go up 3. So 1, 2, 3. There we go. That's its new location. Pick any point on here. 1, 2, 3. We're trying to slide it up 3. From my vertex looking thing here, 1, 2, 3. That's now going to be above the x-axis. 1, 2, 3, and so on and so forth. So I'm going to go ahead and put the graph together for this one then, and we can see, compared to the original, where is this graph going to be now? All right, so and there we go. Ladies and gents, the original graph in the black ink is right here, and then the new graph in the green ink is 3 higher than the one before it. Let's think about what happened to the ordered pairs then. This point was 1, 0, and now it is 1, 3. What changed? What stayed the same? This pair here was 2, 2, which, by the way, is a ballerina's favorite point. 1, 2 over, 1, 2, 3, 4, 5. So now it's 2 over and 5 up. In the case of every single point here, the x-coordinate remained the same, but every y-coordinate increased by 3. So we're taking all of our y-coordinates and increasing them by 3, and that's what's creating our vertical translation for us. All right? So compared to horizontal translation, what do you think is going to happen? Dun, dun, dun. Let's take this one and go to the left. And let's go to the left just 1 unit this time. Oops, I meant to do that in orange. Life. All right. So this time we're going to the left by 1 unit. This is like a line dance, but not. All right, this point right here was 0, negative 2. We would like it to go to the left by 1. It's now over here. Everybody goes to the left 1, to the left 1. Ooh, that's not the origin there. Okay, all right. So let's look at this then. Look at where the graph was. Look at where the graph is going. This guy here. Okay, there we go. So again, the original graph in black, and this is now in orange, slid over 1. And make it colorful orange, there we go, as opposed to green, so we can hopefully tell the colors apart. Everything went to the left by 1 unit, just as we hoped it would. What did that mean for the ordered pairs? Well, let's see here. This was 0, negative 2. Now it's negative 1, negative 2. What changes? What does not? In this case, because it's a horizontal change, horizontal is left and right, that's our x-axis, all of our x values are actually decreasing by 1, and because it is not a vertical change, the y's, the part that goes up and down, that part stays the same. Notice the shapes here, all 3 of them are the exact same. It's just that we are sliding it up and down, sliding it left and right to make that happen. All right, so far so good? Excellent, excellent. All right, so next, ladies and gentlemen, this is the same exact graph, but this time we're going to focus on vertical compressions and horizontal compressions. These are both compressions, so I want to start by comparing the vertical and the horizontal first before we start talking about the stretches to go along with it. So compression. Compress. What does that mean? Compress. Squish. That's what we're talking about here. All right. A vertical compression, again, vertical is up and down. Compression is to compress, to make smaller, to condense. Squish. Did you watch my hands? Ladies and gentlemen, vertical compression. Vertical compression. Horizontal compression. Ponder that for a second, but let's just focus again on this guy for the moment, and we will start in green. And let's say that we would like to do a vertical compression by a factor, ooh, that looks like an important word, by a factor of 1/2. All right, so to squish something, to take half of it, that number fits with that word. To take half of it is to compress it. And by a factor, that is important, all right? So this was all sliding, this is left and right, this is adding and subtracting. Factors are things that we multiply. And so if we think about this, this point right here, let's see, this point here was 4, 6. I'm going to actually write the ordered pair 4, 6. And if I would like to compress this vertically, take it and push it basically toward, what is it we're going here? We're going toward the x-axis. And we are taking half of what it was. So if it was at a height of 6, now it's at a height of 1, 2, 3 instead. So the point 4, 6 becomes the point 4, 3. Again, we are doing a vertical change, so we are affecting the y, we are not affecting the x. So everything here is being cut in half. So this was at a height of 2, now it's at a height of 1. This one is going down -2, now it's only going half of that, down -1. This one up 1, well now it's going to go only up a half instead. And for those of you that just heard the cat in the background, that's my cat. One Take Studios, people. This is what we got. All right, so what does that mean about our new image? This guy's going here. Lovely. This guy's going here. There we go. Very, very interesting. By taking all of our y values, again vertical, this is a vertical change, and cutting them in half, we have smooshed the graph this way. Notice that the points that are actually on the x-axis, what's the y value when you are on the x-axis? The y value is 0. What happens if you take half of 0? It's still 0. When you are doing a vertical compression, you're pushing things towards the x-axis. Consequently, any point that is on the x-axis doesn't actually change. That's going to be important here because we're going to compare that again in a second. All right, so as opposed to, what if we did a horizontal compression instead? And again, we want to go, let's, for equal comparison's sake, by a factor of 1/2. Well, okay, horizontal. Horizontal is this way, left and right. Compression. Again, compresses to squish, but this time it's horizontal, so we are squishing from the left and the right, and we are squishing it towards the y-axis instead. So let's go back to our point 4, 6 here. What does that mean? Instead of going 4 over and 6 up, we're only going to go half of that. We're going to go 2 over and 6 up. It's not the same thing. You can tell already it's not the same graph. All right, so it's a completely different change here, although they do have some similar tendencies from time to time, so we want to be careful. I have a good illustration for you coming up here. Just hang on there. That guy goes there. Again, half, 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 half of where we were. So we are not changing anything. Let's see, how many is that? 1, 2, 3, 4, 5, 6. So 1, 2, 3, half, half, half. And, ooh. Where's the vertex? Because this is my black ink, that's my green. What happens if I take something that's on the y-axis and I push it towards the y-axis? That's right, it doesn't go anywhere. So in this case, our vertex did not even change. That's exactly the same. So we got these guys right here, there we go. All right, so when we squished it towards the x-axis, we end up with this green graph out here. And when we squished it horizontally, horizontal compression towards the y-axis, we get this orange graph right here. So we can see some definite changes going on. Notice, again, what changed. Did you remember what I said about this one for the intercepts? Where it crossed the x-axis did not change because you're moving it towards the x-axis. Horizontal compression, what was it that didn't change this time? We're pressing it towards the y-axis. Anything on the y-axis did not change, but the x-intercepts actually did. So vertical compression, your x-intercepts do not change. Horizontal compression, your y-intercepts do not change. That's a key factor for identifying those. You might want to make a note of that. All right, okie dokie. What does that mean about the ordered pairs? Real quickly here before we switch pictures again. We said that we can figure out what's happening with the ordered pairs on these. Vertical, that's going to change the y's, we said. So we said the x's stay exactly the same, but all of the y values got cut in half. They get multiplied by a half. Green pen not cooperating. There we go. All right, so all the y values got cut in half, multiplied by a half. And over here, it was horizontal, so that's left and right, that's the x movement. So for this one, all of the x values were multiplied by a half, and the y values stayed exactly the same. Okie dokie, I got one last big thing for you here. All right, so now here's the thing. Look at the orange. If I asked you, without looking at any of this, to describe the orange graph compared to the original, how many of you would have said it got pressed in from the sides, and how many of you would have said it got taller? Because see, here's the issue with that, is that we've got some strange things that are at play with stretches and compressions, which is why I started with a compression by compression comparison. Well, what happens now if I do a compression and a stretch comparison? And yes, you may have seen, I brought silly putty today. Boom, there we go. All right, this is a spherical piece of silly putty right here. And I'd like you to think for a second. Vertical compression, if I want to take this thing right here and compress it vertically, all right, again, vertical, this direction, and compress means that we're going to take this, and so watch what happens with my silly putty when I do a vertical compression, all right? What happens with this thing? I pressed it from top and bottom. I compressed it vertically, but what happened to it? It also went sideways. So while this was a vertical compression, it has the appearance of being a horizontal stretch. Yikes, how are we going to tell the difference with these things? Because isn't there a ton of similarity here? I think there is. All right, I'm putting my silly putty back into a sphere again, or something darn close. All right, so here we go. We got this time. What if I'm doing a horizontal stretch? That means horizontal, that's left and right, and stretch should be to pull, so I'm going to pull it instead. Huh. Well, even though this was achieved by pulling it outward, horizontal stretch, it also kind of looks like the vertical compression because I get the same effect from squishing it down as I do from pulling it out. All right, so these guys, you have to be very careful with them. It is possible, if you have a simple enough function, that a vertical compression can be the exact same thing as a horizontal stretch. But for any graph that is even slightly more complicated, these are not the same thing, but man, do they look similar. All right, so you may have noticed I just borrowed the exact same vertical compression information from the previous page. So we're starting with, again, the black ink is my original graph, and I already have my factor of 1/2. And we said that for a vertical change, that means that our x's are staying the same, and vertical impacts the y's because y-axis goes up and down. We took half of the y values just like that. All right, so let's think what that would mean for a horizontal stretch, because again, we really want to compare these. And this time we're going to say by a factor, again, using the word factor, because stretches and compressions are both multipliers. Repeat, stretches and compressions are both multipliers. Translations, adding and subtracting. Stretches and compressions, multiplying. So by a factor of, well, what number makes sense here? Because compressing was half, that was making it smaller. Stretch does not make something smaller, stretch makes it bigger. So let's say that we do a factor of 2 instead this time. So think about what that would possibly mean. Horizontal stretch. Horizontal, that's going to be my x's, stretch, and we're pulling them out, we are doubling, we are doubling all of our x values. And the y's will stay the same. So even though we just illustrated with the silly putty that these two things can be very similar looking, I want you to see the differences because they're created differently and therefore they give you slightly different outcomes. So let's go to our points here. Let's go with this guy. All right, this was 0, -2, and I'm going to double 0. Oh, well, wait a minute. So that one's not going to change again. What if I go here? This was 1, 0, and I'm doubling my x's to stretch it out. That's going to be at 2, 0 instead. This guy was 2, 2. Now he's going to be 4, 2. All right, so again, we can see 1, 2, 3, 1, 2, shoot. 1, 2, 3, 4, 5, 6. That's going to be here. So I'm going to get at least this side going for a moment. So you can see, again, our horizontal stretch. We are pulling it outward, and it creates something similar to what was happening with the vertical compression, but they're not the same thing. All right, they are different. You just got to keep your eyes peeled, look carefully. With these guys, let's see, originally, where were you? You were 2 over, so you're going to be 4 over now. Again, a stretch, we are doubling our x's. This was 1, 2, 3, 4, 5, 6, 7. This guy's way out here now. All right, so you're just moving each of our points, changing it. There we go. All right, so ladies and gents, like I said with the silly putty, the movements that we make, a compression, a vertical compression, and a horizontal stretch, have a very similar look overall, but they're not identical. All right, both of them appear to be squished this direction and pulled this direction, but notice again our intercepts. When we are doing a vertical compression, when we are squeezing everything towards the x-axis, that changes the x-intercept. So for vertical compression, again, the x-intercept does not change, but the y-intercept does. This guy here, horizontal stretch, we are pulling everything away from the y-axis. What does this mean? Anything on the y-axis, that y-intercept will not change, but my x-intercepts will. That is how you're going to identify these for your changes that are taking place. All right, so later video I will get into the equation portion of this and what this means and what this looks like. But ladies and gentlemen, you have a huge step in the right direction today. All right, so these are all of our transformations. Keep your eyes open and yeah, have fun with it. All right, thanks. Bye.